Hello everyone, my name is Ali. Today me and my friends Altun, Emil and me, we will talk about deterministic finite automata. So what's automata? It's like a machine. For example, you have a language, you wrote an automata and you want to know whether the word is from this language or not. So let's consider an example of a machine that has two buttons, 0 and 1, and a display that shows true or false. So anytime you push the button 0 or 1, it goes somewhere or to itself, to some states. We have states. We will denote them as points. We have final states. We will denote them also as points, but we will cycle them. We will have a beginning. We will have arrows that will show where to go. So let's begin from an example to make it clearer. So we want an automata that will tell us true if it ends with 1. So automata should end with, so word should end with 1 in order to be true. So we write initial state. It will be here. Initial state doesn't satisfy our condition because it doesn't end with 1. So from each state we should go both to 0 and 1. Somewhere it should go anyway. So we go to 1. So this condition satisfies us, and we denote it as a final state. But what about 0? What if we go from initial state to 0? It doesn't end with 1, but it will go to itself in order to wait for, it's 0. It will wait for 1. So for example, we have a word 1. It will satisfy the condition. It will stay here, 1. We will have I forgot to, from final state, if we go 1 again, it will be true because it also ends with 1. If we go 0, we will go to the beginning, which is not a final state, and we will wait for ones in order to complete our automata. So 1 is satisfiable, so it will go from initial state to final state and will give us true. 0, we don't know how many times, any number of zeros, and 1. It will also satisfy our condition because it ends with 1. So whenever we push 0 at initial state, if we are at initial state and we push 0, it will not change anything. It will just return to the same state. So consider an example, for example 1. So from initial state we go 1, then for example 1. It will be true. Let's go again 1. It will be true. It all ends with 1. Because whenever at the final point we go to itself with 1, it will be satisfiable for our condition and we will get true. But what if after 1 we put 0? We go 1 to final state, but after that we go 0 to this state, which is not final. So what should we do in order to have true? It's false, because it stopped at this point. In order to have true, we should stop at a point that is cycled. So what should we do in order to repair the situation and get true? we should write after 0, 1. We'll go to final state. And any number of ones will help us.
So, hi everyone, my name is Altun, and after Ali, I want to show an example of automata for you. For this reason, I want to have a condition. In our condition, it says number of ones should be divisible by 3, and at the same time it says it should end with 0. Yes, it's our problem. Yes, let's have a look. Firstly, we should have initial state. Initial state. You see that there is no anything and it's empty, and we know that 0 is divisible by 3, and for this reason it satisfies first condition. Number of ones should be divisible by 3. Yes, it's divisible. However, we don't have a second condition. It should end with 0. For that reason, we come to the end. It's 0 and circle. It's a final state, and it's 0. If we push 0, it will come to the 0. Yes. Then yes, yes, to the final state. Yes, and if we start 0, it will come 0. What if we have 0, 0, 0, 0, 0, 0? It will be in the same place. Yes, we should have this. We can have this after all this, but we should write now 0. Let's have a look if we have 1 at the beginning. At the beginning, yes, 1. It's 1. Yes, our condition is it should be divisible by 3, but the number of ones is 1. If we divide it by 3, it will not be divisible. So for that reason, our first condition is not satisfied. But if we should consider 0, if we have 0, firstly, yes, we came, if we have 0, it will be in the same place. Then we continue this, and if we have again 1, 1, it will be 1, 1, or 1, 0, 0, 0, 1. It will be continued, but it will not be satisfied. 2 is not divisible by our ones is our number of ones is the 2, and 2 is not divisible by 3. So that for that reason we do same thing. If we have 0, it will be in the same place, and we continue this issue. And if we have again 1, 1, 1, yes, 1, 1, it can be 0, 0, 0, something. Yes. And now the number of ones is 3, and 3 is divisible by 3, and the number of ones should be divisible. This condition is satisfied, and we should have this condition. It should end with 0. Yes. From here we come. If we push 0, it will come to this to the final state. Let's write 0. And we should consider other cases, which is if we have 1, 1, 1, or we have zeros here, if we have 0, it will come in the final state, and if we have 1, it will come to this state. Why? Now I will say why. Because it's the same case with the 1 divided 3. It's again remainder is 1, and if we push 1 here for divided 3, it's same case with this. And again from here we should come to this place, and it's 1. Then we have other case. It's let's consider if we said it should end with 0, but what if we have 1 1 or something from here, some ones from here. From final state we come to this place. Why? Now I will say why. Because now it's the same case with this one. We have 4 or 5, or it doesn't matter, ones, and it will come to this place, and our automata is ready for you.